In Level 1, we will be writing complex expressions in standard form and simplifying radicals. In the past, whenever we had a negative under a radical, we just said it wasn't a real number and we moved on. It's still not a real number, but we have something, a symbol that we use to work with imaginary numbers, and that symbol is I. I represents the square root of -1. So a problem like part A, the square root of -16, whereas in the past we would say this is not a real number and move on, we can simplify it if we think of this as the square root of -1 times 16, which is the square root of -1 times the square root of 16, and we call the square root of -1 I, and we call the square root of, well, the square root of 16 is 4, and so we get 4I. We always put the I second. So we were able to simplify the square root of -16. Now I has some properties. If you square I, this would be the square root of -1 squared, and the square and square root would cancel and we would just get -1. If you raise I to the third power, that is like I squared times another I, and we already said that I squared was -1, so this is -1 times I, and we get -I. So I to the third power is -I. And then I to the fourth power would be I to the third times another I. We just determined that I to the third is -I, and if we multiply that by another I, we get -I squared. But we also just determined that I squared is -1, so this would be -1, and those negatives would cancel out and we get +1. So I to the fourth power is +1. And this pattern is going to continue. We'll talk more about the higher exponents on I as we get into level 3. For now, we're just going to simplify some more basic expressions with negatives underneath radicals. Okay, looking at part B, the square root of -25 is 5I. The square root of -9 is 3I. If I multiply these together, I get 15I squared, and I squared is -1, so this is -15. In this next part, we always want to take out the i's before we start simplifying. So this is the square root of 8I times the square root of 2I plus the square root of 20I. So I'm just taking out the -1 from underneath the radical and writing it as I. And then I could simplify my radicals and then distribute, or I can distribute and then simplify my radicals. I'm going to simplify radicals first. So 8 is 2 radical 2, I. Square root of 2 can't be simplified. And the square root of 20 is 2 radical 5, I. And now I'm going to distribute. So I multiply this first term times this first term, and we get 2 times, and then we multiply the radical parts together. Square root of 2 times square root of 2 is square root of 4. We multiply the i's together and we get I squared. And then to simplify this a little bit, square root of 4 is 2, so this is 2 times 2, and I squared is -1, so we get -4. And then we distribute to the next term over here also. We can multiply the 2's. 2 times 2 is 4. Radical 2 times radical 5 is radical 10. I times I is I squared, and this was a positive times a positive. Okay, 4 radical 10 can't be simplified, but I squared is -1, so we get -4 radical 10. And that's our final answer. In this next part, we are going to review simplifying using the conjugate because we will eventually do almost the same thing with imaginary numbers when we get to level 4. So we need to review how to simplify using a conjugate. Remember, the goal of using a conjugate is to get rid of the radical in the denominator. And we multiply the fraction by whatever expression is in the denominator, but we switch whatever sign is in the middle. So I make this 2 minus radical 8. And we do the same thing on the top. So we multiply by 2 minus radical 8 over 2 minus radical 8. And remember, anything over itself is 1. So I'm really just multiplying this fraction by 1, which is why it's legal. I'm not changing its value in any way. Now on the top, I need to distribute. And we get 3 times 2 is 6. 3 times negative radical 8 is negative 3 radical 8. That can be simplified. I'll come back to it. On the bottom, I'm multiplying these two binomials, so I have to FOIL and multiply the first parts. We get 4. And multiply 2 times negative radical 8, and I get minus 2 radical 8. These inside parts make plus 2 radical 8, and my last terms, positive radical 8 times negative radical 8 is going to be negative square root of 64, which is just 8. Now, what should always happen when you multiply an expression by its conjugate is you should always get two terms in the middle where one is positive and one is negative, and they cancel out. And then on the bottom, we just get 4 minus 8, or negative 4. On the top, I still need to simplify. We get 6 minus 3. Radical 8 is times 2 root 2, which would be 6 minus 6 root 2 over negative 4. And then all of these can be divided by 2, so we can reduce that. If we divide each term by 2, we get 3 minus 3 root 2 over negative 2. And that would be our final answer. Okay, in the next one, feel free to try it on your own. You can put me on pause if you want, but I will go through it. Same thing, we take the expression and multiply by the conjugate of whatever's in the bottom. So I'm going to multiply by 1 plus radical 2 over 1 plus radical 2. On the top, we have to distribute. 2 times 2 is 2. 2 times radical 2 is 2 root 2. 1 times radical 5 is radical 5. And square root of 5 times square root of 2 is square root of 10. Then on the bottom, 1 times 1 is 1. If you want to, you can skip your outside terms and your inside terms because we know they're going to cancel. So I'm not even going to write them because I know that they're going to cancel out. And I'm just going to multiply my last terms. Negative radical 2 times positive radical 2 makes negative 2. So then on the bottom, we just get a negative 1. So we get 2 plus 2 root 2 plus radical 5 plus radical 10 over negative 1. And a simpler way to write this would be to divide everything by negative 1. And oops, minus radical 5 minus radical 10. And there we go.